So in section 4.6, where we do directional derivatives and gradients, we're going to determine a directional derivative in a given direction for a function of two variables. What does that mean? We're also going to determine the gradient vector and so we'll talk about those things. Okay, so let's suppose for a moment you and a friend are on a mountain. Okay, so you and a friend are on a mountain, okay? And you can only walk this is the y direction, so I'm going to call that north. And then the minus y I'm going to call south. The x I'm going to call east, and this is west. So you can only walk so suppose you can only in the x direction, you can only walk east and west or north and south. Okay, so if you can walk east and west, you can walk in the x direction. So east and west is in the x direction, and north or south is in the y direction. So when I ask you, what is the partial of f with respect to x? So here again, z is equal to some function of x, y. And when I ask you, you can only go in the x or y direction. Basically, what we are trying to figure out is what is the derivative or the slope, in a sense, in the x direction. So this gives the slope, i.e., the derivative in the x direction. And so that's going to give you east or west, okay? And f sub y is going to give you the slope, i.e. the derivative. Oh, this is supposed to say x direction, in the y direction. Okay, do you understand?
Yes.
Okay, now suppose you want to walk northeast. So let's see what northeast would be. So this is north, this is east, this is west, and this is south. So you want to walk northeast. So instead, you don't want to walk north or east, you want to walk this way. Okay, so that would be if I were to just go over here 1 and go up here 1. So that would be in the direction of I, the vector V. Yeah, I hate squeezing stuff in. So the direction vector V would be I plus J. In other words, you're walking along the line y equals x, right? If you wanted to walk 60 degrees toward and closer to E, 60 degrees off of east, then you would choose a vector and then make it so that the tangent, is for that angle, 60 degrees. Okay, so that's the direction. So that means instead of walking due east or due west, you say, I really want to walk this way. What's the slope of the function? What's the function doing in that direction? How do you do that? Well, that's where we get what we call a directional derivative. So the directional derivative, how do we compute this monster? It's actually, I love the directional derivative. By definition, it looks awful, but it's really not. Okay. So it's called the it's capital D, the directional derivative of the function in the direction of U. Okay. At the point x naught, y naught, z naught. It's basically going to be your slope in the direction of U, not necessarily x going due east or y going due north or south, but any other place where you want to go. Okay. It is defined to be the limit as h approaches 0 of f of x naught plus a1h, y naught plus a2h, and z naught plus a3h, all divided by, oh, I forgot a piece, minus f of x naught, y naught, and z naught, the whole thing divided by h. Okay, now, if the limit exists, yep, thank you. If the limit exists, base and f is differentiable at x naught, y naught, z naught, then we get what we call the directional derivative. And the directional derivative, df du at f, at the point x naught, y naught, z naught, becomes the derivative of f with respect to x at x naught, y naught, z naught times a1 plus the derivative of f with respect to y at x naught, y naught, z naught times a2 plus f sub z at x naught, y naught, z naught times a3. Okay. Now, if A is not a unit vector, you have to make it one. You have to make U equal A over the length of A. Okay, So this is the directional derivative, and I'm going to say of f in the direction of the vector A, A1, A2, A3. Okay. 3 minutes, one quick example. Okay, so find the directional derivative thank you, of f of x, y, z equal to x squared. I'm sorry, z equal to f of x, y. I don't know what I'm doing. Z equal to f of x. Oh my gosh, I hate when I'm down to the second. Equal to f of x, y equal to x squared plus y squared at the point 1. In the direction of A of V equal to 2I minus 3J. And we will pick up here tomorrow.
Okay, I'll see you tomorrow.
All right, see you tomorrow.
Bye.
Bye.